See, students, very important thing is that why this geometric construction we have to study. Geometric constructions we have to study because of the Euclid. Euclid was a scientist who relate logical geometry into the actual geometry which we were taking practically using. What is the difference between the logical geometry and the practical geometry? Practical geometry is the things that which we are using the logical geometry. Example, if suppose we are talking about the perpendicular bisector, if we are talking about the perpendicular bisector, then perpendicular bisector is a line which divides the segment into two equal parts as well as it is perpendicular. Then all the points of the perpendicular bisectors are always equidistant from the extremities. Now, this particular principle we are using in building constructions also. Now, this geometry, logical geometry, we have used in the building construction, or there are many like cuboid. If we are talking about the cuboid is also we are using in the building construction. What is that use of the cuboid in the building construction? That is the pillar or the beam. These are the basic things of the building construction which has directly depend on the logical theory, that is the cuboid. Okay, now, so therefore this particular Euclid has got a new idea, and hence he is called as the mother of or father of geometry. New idea that logical statements he prepared, that is called as a axioms, then it is called as a postulates, then it is called as a theorem. Theorems are depend on the postulate or the axioms. Axioms are self-truth statements. Axioms are self-truth statements. These self-truth statements then further makes us to think about the mathematical sentences logically, and that mathematical sentences logically which can be proved are called as theorem. And on the basis of theorem, we can apply these theorems to construction. Anything can be constructed out of these theorems. And this particular chapter comes under that one. That is the geometrical construction. Here we are going to study how to make the constructions of different things by using theorems. Now I'm going to explain while explaining the paper how we are using theorems in construction. This is the additional factor that which I am going to tell you. Now in your paper there was a first question, that is select the correct alternative. It is very simple. The number of tangent that can be drawn to a circle at a point on the circle is the only one is the answer. Now why only one? If you think about it, then you will observe that there exists one and only one perpendicular to any segment from any point. From any point, only one segment which is a perpendicular can be drawn, and hence there exists one and only one circle, one and only one tangent. That is from the point which is on the circle. The second thing, if triangle ABC is similar to triangle PQR, very simple. They are similar. AB upon PQ is equal to 7 upon 5. Then which triangle is the bigger? The bigger triangle is that particular triangle whose side is bigger in the ratio. In the ratio, whose side is bigger? Whose side is bigger? The AB is bigger than the PQ, because PQ is 5, AB is 7. So automatically AB containing triangle, which one triangle is there? That is triangle ABC. And therefore triangle ABC is the bigger triangle. Such a simple answer is there. Now, there is the second question. Second question gives us construct a tangent to a circle with center P and the radius 3.2 centimeter at any point on the M. Just it is connected to the first question, first fill in the blank. We can able to draw one and only one. Now, first we will understand what are the construction steps. What are the construction steps? And then I will tell you how the theorem is implemented, or how the theorem is used here to say that this is only the tangent and that is only one and only one. How? Let us first understand how to draw the tangent from the given point on the circle. Now, draw a circle with center P, keeping 3.2 distance in the compass. In the compass, we have to take 3.2 distance and we will draw the circle. After drawing the circle of 3.2 centimeter, we'll select any point of the circle. Circumference of the circle nahi bolunga main, because circle is the name of the figure, circumference is the dimension. Dimension pe kabhi point nahi liya jata. Circle figure pe point liya jayega, and that point of the circle I have selected M here in the figure which has been shown in the paper, answer paper. Now I have taken M point is a point from which we have to draw a tangent to the circle. To draw the tangent to the circle from point M, what we are doing, we are drawing the perpendicular. What is the meaning of perpendicular? How to draw the perpendicular, sir? That we can take some distance in the compass and draw two arcs on PX. On PX, one arc here and one arc there. And then what we have to do, keeping some more distance or less distance or keeping equal distance, we will take that compass and keep on both the arcs. First, on one arc of the left hand side, we will keep that compass and mark one arc above, one arc below. And then on right hand side, the another arc which is there, we will just mark one above, one below. Because of that crossing arc, we will get 2 points, and we join to that 2 points with the M, you will get the tangent. You will get the tangent. That is raw PM, draw ray PM निकाला अपन ने, फिर बाद में draw a line perpendicular to PX. Now, my question is, perpendicular कैसे निकाला मैंने बता दिया. But now my question is, how we can say that line L is the tangent only? Why it is tangent? Because we have studied one theorem. A perpendicular line to the radius at its outer end. A perpendicular line to the radius at its outer end is always a tangent. So what we have done in the construction, here in this, we have taken PM as a radius, and we have drawn at M to PM perpendicular line. That perpendicular line, it is the theorem gives us in construction that idea that when we draw the perpendicular at its outer end of the radius, then we will get the tangent, and therefore we can positively say that L is a tangent. This is the basic behind it, the logical basic behind it, that which gave the idea by the Euclid. Okay, then next question will go. In the next question, draw a circle with center O and the radius 3.5. Take a point P at a distance 5.7 from the center. Draw tangent to the circle from point P. From point outside the circle, there can be drawn two tangents. We can able to draw the two tangents. Now, how to draw that construction I am telling you. After telling you the construction, I will tell you which theorem is responsible to say that these are the two tangents. I will tell you later on. First, we'll understand what is the construction. What we will do, we'll take 3.5 distance in the compass. We'll mark the circle. After drawing the circle, what we are going to do, we are taking in the from O distance, from O center. We'll take 5.7 in the compass, or we can take the scale, keep the scale on that one, 0 on O and 5.7 पे एक mark करेंगे. That point is P. After marking that point P, OP is the distance which is equal to 5.7. After getting that P from which we have to draw the circle, draw the tangent, what we are going to do, we will join OP and we will draw a perpendicular bisector of OP. A perpendicular bisector of OP, how to draw? Taking more than half distance in the compass, we'll mark one arc above, one arc below, and the crossing arc from both we will draw, and because of that crossing arc, we'll get 2 points and we will join. Now, this particular line which is passing through M is the perpendicular bisector of OP. When it is a perpendicular bisector of OP, means M point is the midpoint. M point is the midpoint. When M point is the midpoint, so what we will take? We will take MP itna distance, yeah, MO itna distance. We will take MP distance or MO distance. By taking MP distance and MO distance, we will draw a circle. Here, in our diagram, we are not drawn the full circle. You may draw, you may not draw, but you have to fix at least 2 points on given circle. These new circles, 2 points, that is point A and point B. how much distance should be taken as a radius for this new circle? That is OM. By taking OM as a distance, definitely this circle will pass through P also. Why it will pass through P also? Because OM and MP, they are equal. Why they are equal? Because we have drawn the perpendicular bisector. Because we have drawn the perpendicular bisector. Then afterward, by getting 2 points A and B on this of the circle, then what we are going to do? We will join it with the P. PA and PB. This PA and PB, they are tangent. They are tangent. Why? Why they are tangent? PA and PB, sir, tumne to perpendicular. You have drawn the perpendicular bisector. You have drawn the another circle, and you are saying that they are the tangents. Yes, they are the tangent. Which theorem is applicable here to say that PA and PB are tangents? I will tell you. When we draw a complete circle, which is M as a center, this new circle that which we are forming, M as a center and MO as a radius or MP as a radius, when it will pass through P, so OP will become a diameter. OP will become a diameter and OM will become a radius. Now, OP being a diameter and this circle, on the circle, there is a point A. On the big circle, which we are drawing to draw the tangent, two tangents, on that A point is such, of the circle, big circle, of the big circle point A is such that which is on the big circle. And if I join OA and AP, what you will get, what you can say about OAP? Measurement of OAP will be 90. Why measurement of OAP will be 90? Reason is not that AP is a tangent. We don't know whether AP is a tangent or not. We are fixing whether AP is a tangent or not. To show that AP is a tangent, we are saying that join OA and AP. Because of joining OA and AP, what will happen? OAP will become 90 because the big circle diameter is OP and any point on the circle, on that big circle, that is A. Any point on that big circle, if we take and if we subtend the angle, subtended by the diameter, that OB is the diameter, we are subtending angle at A, then it will be always 90. It will be always right angle. Therefore, angle OAP up. Now, I'm going to tell you direct theorem that which we are using in this particular. That is, OP is a diameter. Therefore, OAP, that circle is semicircle. And when it is semicircle, that semicircle, on the semicircle, there is a point A. So the angle subtended by the angle which is formed at A just by drawing OA and OP will be 90 because inscribed angle theorem. That is, OAP is equal to half of semicircle. What is the half of semicircle? That is 180 ka half. What is that? 90. So OAP will be 90. And as soon as OA is perpendicular to AP, means definitely AP is a tangent because it is perpendicular at the outer end of radius, another theorem that which we have used. In this way, these basic theorems, Euclid gave this idea. These basic theorems that which we are using to construct, and that constructions we are using in the building constructions or different types of satellites we are preparing, many where we are using this particular construction. Even when we tailor ke paas jate hai, and we are just saying that mera shirt sila do, usme bhi mathematics aata hai aur usme bhi theorems ka application aata hai. Remember this one, and this is very important thing, that wherever mathematics construction is coming, we are using theory in that one, and that theory gave the idea by the Euclid, and Euclid gave us so many ideas about it. Now next construction. Now this one, triangle ABC is similar to triangle LBN. In triangle ABC, AB is equal to 5.1, angle B is equal to 40, BC is equal to 4.8 centimeter, AC upon LN is equal to 4/7. Construct triangle ABC and LBM. This construction about the triangle, which is very simple. The first triangle you can construct, that is ABC is equal to, AB is equal to 5.1, B is equal to 40 and BC is equal to 4.1. That triangle we can draw. ABC triangle nikal diya. Now divide the segment BC into 4 equal parts, if you are observing. And you know, in lower standards, you have drawn one angle in that one. And then we are dividing that particular ray by any taking distance, the equal part of the segment. That you know, I don't want to repeat it, because if I will repeat it, the volume of this particular answer paper will become much more. That you know, I'm assuming that you know, you can divide the BC into 4 parts, 4 equal parts. After doing that one, we will have to take the same distance and go up to n. Go up to n. Then see, step 3, that is mark point n on the ray BC such that of Bn is the 7 times each part of the segment. Means we have taken 1 part distance, then second, third, fourth, and then that same distance we are just marking 3 more additional points. So that 4 point and this 3 point, totality is the 7 point. So Bn is 7. At the same time, BC is 4. 4 by 7. 4 by 7. Now what we are doing, 4 by 7, okay. Now what we are doing, we are drawing a point. Draw a line parallel to a point. Kaisa draw kiye? By taking 5.1 distance in the compass. Just marking A. Then we will join CA. After joining CA, what we are going to do? We are going to draw a parallel line to CA, that is ln from n. Now, how to draw the parallel line to AC? Just by using the corresponding angle test. Theory, I have used theory. Corresponding angles when are congruent, the lines are parallel. So what I have done, I have drawn one angle at C and same congruent angle. Congruent angle, how to draw, you people have done it. So I'm not going to explain you how to draw the congruent angle. Now at C, we have taken some distance and marked the some arc. And same arc we have drawn here. And then we have taken the angle measure and that crossing arc we have drawn. And there will be ln. ln is parallel to AC just by using the congruent angles when they are corresponding. When they are corresponding and they are congruent, means the lines are parallel. Therefore, AC is parallel to ln. And therefore, there are 2 triangles, that is ABC and LBN. One side, that is BC upon BN, will be automatically 4 upon 7. In this way, we can able to construct the constructions by using different theorems. Next theorem, next question is very simple. That is triangle ABC and triangle PQR. We want to show that there are certain dimensions. That is AB is equal to 5.4, BC is equal to 4.2, AC is equal to 6. And AB upon PQ is equal to 3.2. Construct triangle ABC and triangle PQR. Of course, this particular construction is totally dependent on the theory. That is the properties of the similar triangles we are using. When the triangles are similar, their sides are in proportion. So we have taken the sides are in proportion. AB upon PQ is equal to BC upon QR is equal to AC upon PR is equal to 3.2. As the side AB, BC, AC are known, we can find out the lengths of PQ, QR and PN just by using the theory part. That is when the 2 triangles are similar, their sides are in proportion. Therefore, using that particular property and one ratio is given, that is 3/2. So therefore 5.4 upon PQ is equal to 3/2. Therefore, PQ is equal to 3.6. 5.4 upon QR is equal to 3/2. So QR is equal to 2.8. And 6.0 upon PR is equal to 3/2. Making cross multiplication, we can find out the PR is equal to 4.0. And after taking out all the 3 dimensions by SSS test, see, theory we are using. By SSS test, we are just drawing another triangle of the given measurement. One triangle. First triangle is of the given measurement. And second triangle is of the proportional sides using we have constructed another triangle. So definitely 4.8 upon 4.2 upon 2.8, we will get it 3/2. 6.0 upon 4.0 will be 3/2. In this way, just dividing the side correspondings, we will get the 2 triangles are similar. So here also we are using SSS test. So in every construction is a practical purpose. Construction is a practical one. And we are using that construction practical word we are using by using theory, we are making it into the practical construction, and constructions we are using in day-to-day life in different constructions purpose. Okay, now draw a circle of 3.4. It is nothing but the same sum as like that of the second, I think. That is, draw a circle with radius 3.4 and center E. Take a point F on the circle. Take another point A, which is EFA, that is collinear, and segment FA is 4.1. Draw a circle to the circle, sorry, tangents to the circle from point A. Steps of construction, which is very simple. Once again, we will draw a circle of radius 3.4 with the center E. I'm just showing you construction, come on, see. Second, draw a Dekha construction, I'm just going up. There is a E center and 3.4 center, and we have drawn one circle. After drawing one circle, what we are doing, we are just drawing, suppose, one line, EF, at any point on the circle, EF join here. And then what we are doing, mark F on the circle where this particular line is intersecting. After that one, take a point A on exterior, EFA. See, I'm just going down. Listen, EFA, where FA is equal to 4.1. So we have taken that EA line, that which we have drawn, on that EF distance is 3.4. But from F, we are drawing a point of distance 4.1. This is only the difference to make the fix A point. Okay, by just fixing the point A, the same construction we had to go as we have taken in the problem number 2. Now, how to do that one? I'm repeating. Okay, now I don't want to explain you once again the basic of it. That is, suppose we are taking EA from point A, we have to draw a circle. Now, for that, what we are doing, from of EA, we will draw the perpendicular bisector. To draw the perpendicular bisector, what we are doing, we are taking some distance in the compass, marking arc up and down, and from E crossing arcs, we will get the line that point intersect to EFA at M. At M. Now we will take MA or ME distance and we will draw a circle. After drawing that particular circle, that big circle will intersect to the small circle at X and Y. At X and Y. And then we will join AX and AY. By joining AX and AY, we will get, by using the lines, using the scale, line we have to draw, because tangent is a line, not a segment. Okay, so EAX and AY are the two tangents drawn from point outside A, such that EFA is equal to 4.1 plus 3.4, because they are collinear. In this way, once again, we can use the basic at to say whether this particular XA is a tangent or not, sir. So we will join EX and XA already joined. Because of EX joining and the big circle, EA is the diameter. When EA is the diameter, any point on the circle or a semicircle, inscribed angle in semicircle is always 90. Therefore, EXA is angle inscribed in semicircle, that is EXA. Semicircle kaun EXA is a semicircle which inscribing the angle EXA, and that semicircle inscribe the angle. Therefore, angle inscribed in semicircle is always 90. Therefore, measurement of EXA is equal to 90. When the measurement of EXA is equal to 90, so EX is the radius and angle X is the 90. So therefore, a perpendicular drawn from EX, that is the radius outer end, which will give you definitely a tangent. Therefore, AX is a tangent, as well as same logic can be applied to AY, and that will also can be set as a tangent. Thank you. And we have completed this paper. Next paper also will go in the same manner. Thank you, everybody. Thank you. मला दाखव किंवा कसं पाठवता येईल तुला मला.
स्टॉप नाही केलं तुम्ही, स्टॉप नाही केलं
केलं ना.
नाही चालू, स्टॉप करायचं.